All right, so let's take a look at some of the problems that might occur when you have multiple threads running around, right? So first, let's take a look at this. This is one of the more common ones, is called reading uncommitted data. Right? So for instance, here we have two different transactions, and again, depending on the isolation levels, we might decide that there is no isolation, right? So we're going to allow them both to run at the same time. So let's say we have a transaction one, right, is swapping professor sections, right? Maybe I get sick or whatnot, and somebody else will take over for me, or we might decide that I know more about that material than you do, and you know more material on this course than I do, and we swap sections, right? And or it might be that I had these many sections, but then I'm not teaching. I'm dropping a particular section. So one of the sections has more credits than the other, right? And our pay might be based on how many credit hours we teach, right? So for instance, the first transaction is swapping different sections, but we have a different transaction, right, that is running, also calculating our bonuses, right, based on how many sections we are teaching, right? And so transaction one might be updating two sections, right? It says two different records. My record of how many sections I'm teaching, and your records on how many sections you're teaching, right? And but because it's updating two different things, it might be that first updates the section for the first professor, and now they're teaching a new section. So maybe I'm updating one of the professors, but before I get to update the second professor, right, the transaction two executes right in between those two things, right? It's fine. I mean, this happens all the time when you have maybe a single CPU and you have multiple threads running around, right? It might be that you're halfway through the function call, and halfway through the call, your thread goes to sleep, right? And maybe another thread comes up and it's now running around. And so, thread one updates one record, goes to sleep, and then thread two comes around, does a calculation and says, well, how many sections are you teaching, blah, 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 right? And then we'll calculate what the bonuses are, and then it goes away. It ran really, really fast, and it was able to calculate everybody's bonuses. Now, transaction one wakes up again and says, let's see, I had updated Professor 1, now I'm going to update Professor 2, and it's done. It goes to completion. But notice that transaction 2 was working with false information, right, or incomplete information, right? It might be that now the first professor gets a less bonus than the second professor. So that might be unfortunate. So that's what we mean by read uncommitted data, right? That it's we haven't yet made the commitment that we have updated first professor and the second professor. We haven't yet made it permanent, but we're still allowing the second transaction, right, to read this information that we haven't yet committed to. Then we have another one where we might have unexpected changes to an existing record. So you might have a record of a balance for a student that that might have $1,000 in there, and at the same time, by chances, the student goes in and wants to withdraw $50 from $1,000, but at the same time, you might have I'm sorry, no. Yeah, we have $50, initial $50, and the student withdraws $10, but at the same time, the parent is depositing $1,000 into the account. And so the transaction one, reads $50, right, from the database and copies it into its own memory in the CPU in RAM, right? So it no longer has access to the database, right? It copied the $50 into memory. Now, at the same time, the intent is that they want to be able to subtract $10 and update it to $40. If it were the single transaction, then that would be fine, right? I copy the $50, I read it into memory, I do the math, 50 minus 10, that's 40. Now I need to go back and update the balance to be $40, yes? But transaction 2, it might execute in between the time that you have read your $50 and you haven't gone back to update it to $40. So in between, transaction comes along and wants to do an operation of saying, I want to deposit $1,000. That means that I read the same $50 that you read, right? But I want to, my math is that I'm going to increase that to 1,050, and I go in. Actually, I am successful, and I run to completion, and I update it to 1,050. But now comes in transaction 2, the first transaction that had the $50. It updates it to $40, right? Notice that now we have lost $1,000 of the original $1,000 that the parent had deposited are gone, right? So that's unfortunate, right? And so the reason this occurred, right, is that transaction 1 was assuming that what we call a repeatable read. That means that if I read the $50, I'm assuming that if I keep reading over and over, I'm always going to get the same $50. But I haven't checked that. I haven't made sure that is actually the case, right? That if I would have actually kept reading, I would have noticed that somehow there was another $1,000 that I hadn't seen before, right? But because I am assuming that these reads are repeatable, that if I kept reading, I would still get the same $50. So I'm not going to bother. Right? I'm going to assume that it's going to stay $50 all throughout my transaction. I'm assuming that it's a repeatable read, but actually the repeatable reads were not being enforced, right? And because they're not enforced, right, now we get this inconsistency. Finally, we have this example, which is called the phantom records problem. Right? Again, we're going through different types of problems that we might run into, and then we're going to look at some ways to fix them, right, using different isolation policies, right? How to isolate these threads amongst each other. So here's another example where instead of updating records, instead what we're doing here is we might be inserting or removing records while other folks are doing select statements. So let's say we have at the end of the semester, the student body raised $100,000 and they want to divide it amongst all the students, and there might be 1,000 students in the department, and so they come up with that everybody's going to get $100, right? And that's all and good. But say that between the time that you read and count how many students there are, right? You say, the first transaction reads and says, there are 1,000 students. So the math that it's gonna decide on is that it's 100,000 divided by 1,000. Everybody is gonna get $100, right? But before it actually goes and updates everybody's accounts and adds $100 to everybody, before it does that, right, it already has decided that it's $100 for everybody. But before it gets in there, it turns out that there's 10 new students were added to the department and were admitted to the college, and there's now 10 new records. So a transaction came through, inserted these 10 records, and then it left. Now, when in the original transaction that had decided to deposit $100 for everybody, now what they're going to do is that they're going to not update only 1,000 records, they're going to update 1,010 records, right? When they do the update, they say, well, give me all the students, blah blah blah, for this college. I'm going to update everybody, all those records to $100. Now all of a sudden, right, we have created, $1,000 that weren't there before, right? Somehow $100,000 somehow became $100,000, right? Which again, it's inconsistent. These brand new students are also going to have their accounts increase when they shouldn't have, right? Because we had decided that it was divided $100,000 divided by 1,000 students instead of 1,010, right? So again, right, we are in an inconsistent state, right? So these are the various problems that we can run into, and we're going to try and solve these different problems using isolation levels.